On the sun-drenched space coast of Florida, the sailing vessel 9 Lives embarks on a journey not just across the ocean, but through the cutting edge of electric propulsion technology. This is the saga of Treetop Flyer 13, an engineer at heart, who in March 2022, set out to eliminate all fossil fuel from his vessel, embracing the Torqeedo Cruise 12.0 FP motors for a cleaner, quieter voyage. At the core of this system lies the TorqLink communication protocol, designed to synchronize the motor with Torqeedo's proprietary battery management system, BMS. However, Treetop Flyer 13's choice to integrate third-party batteries into his setup introduced a significant challenge: the lack of communication between the TorqLink system and these external BMS units. Question 2. We need a source for the Hageman system's lugsolation, fully insulated cable lugs kits, supplied in Torqeedo parallel bridge cable for power 48 to 5000. The Torqeedo supplied hookup cables are too short. We tried to can we purchase components these individually from Torqeedo to fabricate custom cables, no joy? We have not been able to source anything like these here in the United States, and Hageman Systems does not ship to the US. Now that Torqeedo has introduced us to lugsolation, I don't feel safe using anything else. Having lost a brother to an unprotected 12-volt marine battery connection, I am painfully aware of the dangers of high amperage energy storage. Lugsolation should be the industry safety standard for electrical connections in transportation.
Torqeedo is not do-it-yourself friendly. Everything is in kits applicable to one installation. Torqeedo installers need all individual pieces and parts available online. Another prime example are the salt water zincs. Torqeedo supplies the pod drives with fresh water, aluminum, anodes. The following salt water kits are available. Anode Z in set. #1 Product description: anode set for Cruise 12.0 FP models with folding propeller, 194500, consists of 2 ring anodes for attachment to the propeller, and 1 anode for attachment to the pylon, made from zinc, for use in seawater. Anode Z in set. #2 Product description: anode set made from zinc for use with Cruise 10.0T and Cruise 12.0 are in seawater, consists of 1 shaft anode, 2 half-ring anodes, 2 ring anodes. Anode Z in set. #1 is missing the shaft anode, 2 half-ring anodes for fixed prop, and I am not sure where the 2 ring anodes are to be installed. No installation manual. Anode Z in set. #2 is missing the 1 anode for attachment to the pylon. Installation of Torqeedo POD drives using the supplied fixed-pitch propellers requires purchasing both available kits, detailed above, cobbling parts from each to get the required anodes for the standard installation.
But the seas of progress are not always smooth. By March 2022, the waves began to challenge our hero. During initial commissioning, an error code emerged, a digital siren's call, demanding attention. The integration of third-party batteries with the TorqLink system proved tumultuous, communication was lost, and the dream of hydroregeneration seemed to slip away into the deep. Torqeedo provided new throttles and cables, a lifeline in these troubled waters. Yet, the saga continued.
Sailing Mosquito Lagoon. Everything's performing nominally, with one exception. No regen. I should have full power if I had regen.
This disconnect meant that regeneration, a process where the motor acts as a generator to recharge batteries while sailing, was not functioning. Regeneration is not just about extending range, it's about harnessing the kinetic energy of the sea to power the journey. Technical challenges, communication gap. The TorqLink system was engineered for seamless integration with Torqeedo's batteries, not anticipating the complexities of third-party BMS. This resulted in an inability to manage regeneration safely, risking overcharge or damage to the electronics. Voltage and current management. With no direct communication, there was no way for the system to know when the batteries were nearing full capacity or to safely manage the variable voltage and current produced during regeneration. After splashing 9 lives in April 2023, we spent the next 16 months cruising the space coast of Florida off-grid, ranging from St. Augustine to Fort Pierce, working out life on the water powered by the sun. From charging the batteries, cooking is the biggest challenge. Heating water for coffee every morning and tea every afternoon, baking bread and cookies along with everyday meals is main draw on our batteries. Please like and subscribe, it's free. Also see our next video detailing the refit, upgrades, and general life aboard 9 Lives while working out the bugs, literally, getting to know our composting toilets. Summer of 2024, after reading ePropulsion's operating manual regarding hydroregeneration, performing sea trials offshore, we ran the batteries flat, more on that in the next video. Under tow behind tow boat US Fort Pierce at 10 knots, I thought back to what I had read and I simply pushed throttles forward and bam. The power meter turned from the usual white indicating power usage to blue indicating power generation, 500 watts per side, 1000 watts at 10 knots, minimum appears to be 80 watts at 4 knots under sail, 120 watts at 5 knots.
Port drive on SV 9 Lives seems to be making some noise. Not so much on the starboard. It's fluctuating with no input to the throttle.
The relentless marine environment led to barnacle growth on propellers, reducing efficiency, and corrosion issues in the motors, particularly noted in October 2024 with reports of noisy gearboxes and water ingress. Pulled the port pod Saturday morning, found the sealant insufficient at the base of the cable pipe and the pylon full of mud from 16 months of water flow through this area from the drain hole at the base of pylon through to the interior of the vessel. Proposed solutions for improvement: sealing the surfaces between sections A, B, and C with butyl sealant, 25+ year life and easily removable. Install an inspection plug for the drain hole that can be removed at haul out to check for water intrusion. Add an aluminum closeout plate, 0.062 inch, to the top of the stack, sealed with butyl and fastened with countersunk screws. Update the install manual with a note describing this drain system and its operation.
One interesting thing is that I did not observe any marine growth as in the port pylon. Starboard was leaking as well, maybe not so much as the port, less flow, yet the corrosion around the cable pipe is similar to the port pod. Electrolysis around the cable pipe is exacerbated by high current flow through the cable pipe, and the salt water, electrolyte, inside the pylon. Corrosion is evident on all unfinished surfaces, particularly severe around the cable pipe and the aft mounting stud. Electrolysis combined with the dissimilar metals will eventually lead to intergranular corrosion, where the aluminum casing loses structural integrity as a whole, possibly leading to catastrophic failure. I would give these pod drives a 3 to 5 year service life in the tropical marine environment. Isolating the dissimilar metals and drying out the pylon would go a long way towards slowing this galvanic process. Take notice of the deposits on the top of cable pipe. I am not sure if it is metal or mineral, but I was unable to remove it.
This story isn't just about technology, it's about the human spirit, daring to adapt and innovate against all odds. It's a reminder that even in the pursuit of clean energy, the journey can be fraught with challenges, but also ripe with opportunities for growth and discovery. So here we stand, at the crossroads of technology and the human touch, where every challenge is an invitation to refine, to perfect, to push further into the blue unknown.
9 Lives, heading south, wide open throttle, doing 6.5, almost 7 knots. On D-cell, we got regen going.
Today's challenge is our port pod drive again. Last week I cleaned her bottom, ran her up to speed, solid 7 knots for till to 5 minutes. This morning the port pod was unresponsive, powered on fine, no indication of battery connection or neutral. Traced the issue to the motor control box, smoked the soft start PCB. Master PCB looks to be collateral damage. Replacing the soft start printed circuit board. Master printed circuit board, in addition to the PCBs, requires 10 M8 nuts that fix the bars and a new heat transfer pad for the reinstallation. $500 lesson learned. Before installing new electronics, check the positive and negative leads going down to the motor from the connection box for continuity. If you get a direct short between the positive and negative, then there is an issue with the pylon. March 2025, line of thunderstorms comes through packing 50 miles per hour winds and tornado warnings. Preparing for the onslaught, I turned on the starboard pod drive only to find it not responding to throttle input, no error messages, no other indications of on issue. During initial commissioning, this data power tap connector was problematic. Replaced it and again July 2024, but on this time on the starboard side, and a tightening the cannon plug remedied the issue until now. 9 lives is dead in the water now, no auxiliary power. At this point my port pod drive is in need of a new 5-to-1 reduction gearbox, electronic boards and a pylon assembly. My starboard pod drive I suspect is a bad data cable. I am looking to replace these Torqeedo pod drives. Aquamed is looking like a much more robust design with no reduction